Okay, 4.2 is reflections. A reflection is a transformation, and I'm going to add to it that is a rigid motion. That means that the shape will not change size or shape. It is a transformation that uses a line like a mirror to reflect the figure. The mirror is called the line of reflection. Pretty creative. Okay, your mirror in your bathroom, is it a line of reflection? Or would it be a plane of reflection? Okay, so it would work on the three-dimensional as well. And anytime I talk about video games, this is like old school two-dimensional video games that would use this stuff. Nowadays, we couldn't just use X and Y. We'd have to use X, Y, Z, and then maybe some other variables to do what they want to do. It's a little more complicated. We're going to deal with two-dimension, but these ideas can go into three. You should have got to glide reflection. Glide reflection is a transformation where we do a translation and then a reflection. Okay? And so it's just like what we did yesterday where we did two translations. We're going to move it. Basically, where's my little toy? Here we go. Well, I'm going to have to undo this right here. This is what a glide reflection is. I'm going to move it and then do the reflection. Okay, that's basically what it would be. Of course, you need a mirror, and I didn't have a mirror to show you. So we could call this the mirror. Okay, well, I don't have room. So we will do one graphically in just a second. A line of symmetry. Here it is, a circle. Okay, basically, if my hand is a mirror, this half circle, the other half fills in the circle. That would be a line of symmetry. This particular circle has infinite line of symmetry because no matter where I put the line, it's going to divide it in half, right? As long as I do a diameter. My little tech deck here, you can't just cut it anywhere, right? What if I cut it like this? Would that create two equal halves? What do we think? It might. It looks like it. How about here? How about here? Okay. This one, we can't just cut infinite places, but we definitely can cut. So, let's date this video by having our little thing. How about this? Where do we think a line of symmetry is going to be here? Nowhere. Yeah, nowhere. It wouldn't be even. Okay, so there's lots of things you can do. Of course, this is a three-dimensional shape, which makes it more complicated. We're just doing two. All right, so that's line of symmetry, and they have line of symmetry written in your book twice, so you don't have to define it twice, unless you really want to, and then more power to you. I'm not going to get in your way of making choices about double definitions. All right, this is an important area. Line of reflection. And you can see I made little mistakes right here and right here. So I just marked them out because that's my problem with using pens. They show it better in the video, but you can't erase them. So this is basically in your book, but I just wanted to bring it out because it's nice to have these little formulas. This is on page 165. I think I put 165 right there. And basically, your points are going to take this form AB, and then x-axis, that's what the new point's going to look like. And we're going to look at this on graph paper. These, you probably haven't done. They're a little harder. These are easier, and you can just basically eyeball it, and I'll show you how to do these without using the formula, but we'll also look at the formula. But the nice thing about geometry being a real thing is that there's a bunch of different ways to do it, especially if you go through all the effort and graph it. A lot of times you can just count. Now I wish I had an actual mirror, because then we could do games with the actual mirror, but I don't. I used to, but that was like 7 years ago, and I've had bad luck ever since.
You broke a mirror?
Oh, I didn't break. I mean, I did. I didn't mean to.
Nobody means to.
Yeah. But I think my bad luck is supposed to end this year, right?
It was 7 years ago.
So good. That's good news for us.
Yeah. Remember I saw your fault, Mr. Crowder?
It might be. I'd feel bad if it was all my fault for just breaking a mirror. Caused the whole pandemic.
Very time consuming.
No, somebody would have done it.
I'm not-
Bad luck.
I'm not sure that's real science, but we'll just stick with math for now.
That is true.
Did we get this written down?
No, no, no.
I'm going to straighten it up. That's the wrong way. Well, the nice thing about this, I do have the mirror image on this. That's the student council, and they're working on posters.
Oh, I thought I heard the door wiggle.
Yeah, they're loud.
Oh, see? Yeah.
That is the door.
I'm looking for somebody.
So we are. All right, we got it written down.
Yeah.
Just I can't stop it. It doesn't work that way. I'd have to edit. All right, and that takes too much time right now. So let's look at this problem right here. 3, 4, 5, 2, and let's call it 2, -3. Let's graph this triangle, and then we're going to do something with it. And I'm going to use the magic of technology. You're done with it? I was gonna put the audition because I'm done with that, and it's an MP on the desktop.
Oh, okay. I'll dump it in.
And so you just dump it in the. Okay. All right, that is thrilling YouTube right there.
Yeah.
Thrilling. All right. So yeah, graph this triangle here.
What number is this?
What number is this?
Uh-huh.
I just made it up.
Oh, okay.
I just made up a little example that I figured that we could do, and we could look at stuff, and I could use the magic of technology to reflect it. And then we'll probably go over how to do it without technology. I really probably should have done this. A, B, and C. That way, when I label it, we will, kind of know what's going on. So this is A, B, and C, right? So I can use the formula, and so I'm going to go through how the formula works. First of all, you need to know where the mirror is or the line of reflection. I want you to reflect it about the y-axis. Okay, so basically that means that this is going to be my mirror, yes? Okay, just like your mirror at home, this is a real thing. I look at little c, right? How far is c away from the mirror? Well, then that means on the other side of the mirror, shouldn't c prime be over here? Okay, let's see if the magic of technology can do what I want it to do. So the reflection should look like that, right?
You're crazy, man.
I mean, I'm going crazy with pushing buttons. Okay? it would be better if I put this in the middle. Let's see if that does it better. If I do this fast enough, you can see the reflection, right? Okay. So that was thrilling and exciting. So this is C prime. Let's see how far B is from the mirror. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. A. 1, 2, 3. 1, 2, 3. Right? And so we'll check and see how the formula works. Okay? And so in theory, if I do this, it should look like it just changes colors, right? It's pretty good, right? It's just a little bit. That just means my stuff isn't straight. All right, so let's do the math. If I needed to do the math or I didn't want to graph it for some reason, this is how it would work. The y-axis says negative a comma b. So that basically means I'm changing this sign to this. And I'm basically just doing this, right? Does that make sense? Are those my new points? Okay. So you can do it with graphing, or you can just do it with the points. And sometimes I'm going to ask you just to do it with the points, because in the real world, you don't really graph. If you're programming, you don't just graph it out. You might draw it out beforehand to see how it looks. But in the real world, this is what you're putting into the computer. You're putting in the data. You're putting in the directions. You're not actually drawing stuff out. Okay, so that's that. Let's look at the next one, which is harder, because we're going to use this as our axis. I'm doing it backwards here, but you can't see it, so it's fine. We're going to use this as our mirror, because this is harder to do. This is harder to look at. And so we're going to see if we can do the, no, I don't have something that can do this on this particular piece of equipment, and I'm trying to straighten this up. So I'll give you some points here. We're going to do like 4 comma 5. That's hard to see. 4 comma 5 is going to be A. We're going to do B is going to be like 2 comma 1. And we're going to do C is going to be 6 comma 3. Okay, we're going to draw this little graph here. And we're going to try to get this triangle graphed. Of course, this works with the non-triangles, but triangles are basically the quickest way to draw a polygon, right? Because I only need 3 lines. So 1, 2, 3, 4, 1, 2, 3, 4, 5. 2, 1. And 6, 3. Hopefully I did that right. That'd be nice if I did. Okay, a little bit of error on that. So I'm going to also draw my mirror. Y equals X. So if you don't remember how to graph the line Y equals X, it's basically you start on 0 and go up 1, right 1, up 1, right 1. So this is going to be a complicated looking mirror. Let's see if this shows up on my video. Okay. So this has two problems. First problem is my shape is inside the mirror, right? Second problem is it's hard to look and see how far away this point is from the mirror, because that mirror kind of goes on a diagonal, right? So this is where I'm going to rely on these formulas. And so I look at my formula, and it says if you're reflecting y equals x, you're supposed to switch the order. Instead of writing it in AB, I'm supposed to write it in BA. So by that I mean this. There's my blue pen. A, if I change it to the new order, would be 5, 4. Let's graph that and see if that makes any sense. 5, 4 instead of 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. And it kind of makes sense because that's going right through this line. It's equidistant from that line. So this would be A prime. Let's do 2, 1. That's this B down here, right? What would it be? 1, 2. 1, 2. So that B prime is going to be right here. Let's do C. What's C going to be? 3, 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. I'm going to draw it out and let's see if it makes sense. And if you draw it out, it should make a nice little pretty shape. Okay. Does it look like it reflected? Does it look like the symmetry of this shape is now going right through this line? Okay. So that's about as hard as it gets. I'm going to show you stuff on the book so you know how to do the problems. And we will... I think this is why I turned on the brightness. So I'm going to have you do 3 through 4. So you might not be able to see this great, but it's in your book. 3 through 4, you're just going to determine whether the coordinate plane shows a reflection. And you're going to, if it is a reflection, you're going to tell me x-axis or y-axis. I'm looking at 3. 3 should be easy. What do we think? Is that a mirror image? So which axis do we think we mirrored? Okay. So I'll let you do the rest on your own. Moving on to 7, and this is hard to see. Moving on, now it's not in focus. You're just going to graph that stuff, and you're going to reflect it about the axis. I'm going to do number 10 for you, because we didn't do an example, and so we'll do that in just a second. Moving on 13 through 14, you just graph this and follow the directions and do the mirror images. All right, 17, 18. Okay, we're going to do a translation, and then we're going to do a reflection. So we're going to reflect the translated image. So you're going to start with a pre-image. Then you're going to have an x prime, which is going to be a translation. Then you're going to have an x double prime, which is the reflection of the x prime. Does that make sense? All right, now we get to the easier parts where we're going to do symmetry. We're going to look at that shape and determine how many lines of symmetry you can do. Basically, where can you cut that shape and split it in half? Okay, so we're going to look at those shapes, and we're going to look at those words. And then we'll talk about them when you're done. All right, that's it. Oh yeah, I wanted to do 10 on the video for you, just so you know how to do it. So you're going to have to do 10 also, so just you can do this on your homework. So this is number 10. If you want to do 10 later, I'll just kind of leave it up here. But 10, what is the mirror on 10? Does anybody know? What does it say? Very quiet. Are we asleep? Yeah. Is the mirror x equals 2?
Yeah.
Okay, if you don't remember how to graph x equals 2, this is how. Remember, if it's x equals, that means it's undefined slope. All right, we can kind of see the mirror, yeah? Ish. Okay, and so looking at 10, I'm going to graph J for us real quick. J is 1 comma negative 1. 1 comma negative 1. That would be right here, right? This is J. Where are we going to reflect J to? This is the mirror. It's 1 away. Am I going to reflect J to right here? This would be J prime, right? And so you just need to do it with all those particular points. Okay. I'll let you get started. I'll put on what we're doing on this, and I'm going to finish this problem, but I'm not going to let you work. So this is going to be 168, 3 through, I'll make it exciting, live show here. All 8 through 20 even, 21, 25 all. Okay. I'm going to put that over here, and I'm going to continue working on this particular problem. K is 3 comma 0. And J and L is 0 comma negative 4. I'll draw my picture, see what it looks like. And we'll see if I do it better than I did last hour. I do like to use different colors on this so I don't get confused. So I prefer to use stuff like black and red because they're very different. Or pencil and blue. Or pencil and red. So you're welcome to do that so you can see it. Okay, so now I need to do J. In this case, I'm doing purple because I used red for the mirror. J, I already did. L is 2 away from the mirror. So that means it's going to be over here. This is going to be L prime. And so I can connect the dot here. And K is on the wrong side. So it's 1 over here, so that means it's going to be 1 over here. And that's going to be K prime. And so hopefully I can connect the dots and it's going to look right. Okay, does it look like a reflection? Okay, that's good. That means I might have done it right. Let's stop this.